Next, we'll see about the consensus and decentralized applications. What is meant by consensus process means it is mainly in blockchain network, it involves the coordination and agreement among participating of the nodes for the validity and ordering of transactions. So the all nodes in a network reach a consensus on the state of the blockchain. What are the requirements for the consensus protocol? Here, the consensus protocol used in the blockchain as a distributed ledger technology, it requires certain properties, their effectiveness and reliability. So what are the requirements? In safety requirements, agreement. In who are going to be added to the network, the all nodes must agree on a single value or state and validity. The agreed upon the value or state must be according to some protocols like rules. Third one, termination. The protocol must eventually terminate who are not reach that agreement, ensuring that all nodes reach agreement. Otherwise, the node will be terminated. These are the safety requirement: agreement, validity, termination. Next one, liveness requirements: progress and responsiveness. Progress means the protocol must make progress, it is ensuring the transactions are processed and the network moves forward. Next one, responsiveness. Who are going to performing consensus or new transactions or any node failures or any action is performing in the network, it will be responded. Take it as everything as an event. So that is responsiveness. Coming to the security requirements, it mainly maintain the who are performing maliciously activities in the network. That is Byzantine fault tolerance. Next one, Sibley attack resistance. So the protocol must prevent malicious nodes to create multiple fake identities to manipulate the consensus process. Next one, 51% attack resistance. So more than 50% of the network resources are controlling. It must prevent the group of malicious nodes. Next one, authentication. Only authorized nodes can participate in the consensus process. And data integrity. It mainly maintains the data as who are going to store the data. It does not tampered or any altering the data is not allowed. When you are going to perform any altered data, it will take it as a other block of the data. It maintains the data integrity and it maintains the sensitive data is in unauthorized attacks. It secured the data. We are maintaining the confidentiality. In performance requirements, scalability, throughput, latency. In network requirements, network topology, network size, network partitioning. In node requirement, node heterogeneity and node mobility, node failures. In economic requirements, incentivization, cost effectiveness, fairness. Additional requirements, energy efficiency, flexibility, and transparency. What is mean by proof of work? It is a mechanism of majority cryptocurrencies currently in circulation. It is the choice of the different cryptocurrencies. This is the algorithm used to verify the transactions and create a new block in the blockchain. It was published in 1993 by Cynthia Dovok and Moni Neuer and later applied by Satoshi Nakamoto in the Bitcoin paper 2008. What is the principles of proof of work means? It is a solution that is difficult to find and easy to verify. That is the principle is following. And Ethereum, startingly they are used a POW mechanism, but it is shifted to the proof coin stack. What is the purpose of proof of work means? It is a consensus mechanism to bring all the nodes in agreement, trust one another, and it does not it don't trust each other. One another it will be trust, and all the transactions in the new block will be validated. and it is added to the blockchain. Next, the new block will be added to the blockchain as the longest block of height. And the miners, the special computers on the network, the perform computation work in solving a complex mathematical problem to add the block to the network, hence named as a proof of work. With the time, the mathematical problem become more complex. The features of proof of work is the it is mainly two features have contributed to the wide popularity of the consensus. It is hard to find a solutions to a mathematical problem, and it is very easy to verify the correctness of that solution. How does POW will work? Mainly, it involves the verifying a transactions through the mining process. It mainly focus on discussing the mining process and resources consumption during the mining process. What is mean by mining? So in the proof of consensus algorithm involves we are solving some mathematical or challenge some puzzles that are challenging puzzles are created, so that whenever we are going to solve that puzzle or uh, find out the solutions for complex mathematical problem, the block will be created. That block will be added to the Bitcoin blockchain. So this process we are call it as a mining. Who are going to engaging the mining process? We are call it as a miners. So the miners will get incentives like economic payoffs. Otherwise, they are rewarded some bitcoins and a small transaction fee. The reward will be get reduced by half of its current value with time. So this is the mining process. Energy and time consumptions in mining means to process of verifying the transactions in the block to be added, and we are maintaining the organized of these transactions in a sequential or chronological order in the block, and we announcing the newly mined block to the entire network. It does not take much energy and time. The energy consuming part is solving the hard mathematical problem and link to the new block to the last block in the valid blockchain. When a miner finally finds a right solution, the node broadcast it allows the node or a block to the network at the same time and receiving a cryptocurrency price as a reward provided by the POW protocol. Mining reward. Currently, mining of the block in the Bitcoin network gives the winning of minus 6.25 Bitcoins. The amount of Bitcoins one halves every 4 years. Next deduction in the amount of Bitcoins due at around to 2024 with the current rate and growth. With more miners comes to mine the new blocks getting shorter. Now the blocks are mined found faster in every 10 minutes. So it will be reached to the 21 million. So the Bitcoin network regularly changes the difficulty level of mining a new block. Next, Bitcoin's POW system. It is a hash gun proof of work system as the mining basis, and the hard mathematical problem can be written in an abstract way. The target hash is a number of the header. Hashed block must be equal to or less than of a new block along with the reward to be awarded of a miner. So the lower target is the more difficult is to generate of a block. The target has adjusted to once every 2016 blocks or approximately once every 2 weeks. All the miners immediately stop working on this set blocks and start mining the next block. Common cryptographic protocols used in proof of work, that is SHA-256, SHA-256 was introduced as a part of Bitcoin. Other script SHA-3, script chain, script N are the cryptographic protocols used in proof of work. What are the challenges are facing the proof of work? the 51% risk. The controlling entity owns 51%. More than 51% of the nodes in a network are corrupted. So the majority of the network of the blockchain will be corrupted. And time consuming. Miners have to check over many nonce values to find the right solutions to the puzzle must be solved to mine the block. So it is a time consuming process. And the resources are required for mining or solving the hard mathematical puzzle. It is waste of precious resources like money, energy, space, hardware. It is expected 0.3% of the world's electricity will be spent to verify the each and every transactions end of the 2028. Not instantaneous transactions. It is the transaction confirmation takes about 10 to 60 minutes because it takes some time to mine the transactions and add to the blockchain committing of the transaction. Next algorithm, proof of stack. It is aimed to achieve distributed consensus in a blockchain. A stack is a value or a money we bet on a certain outcome. The process is called a stacking. Why proof of stack means before proof of stack, we must popular why to achieve distributed consensus. Proof of work is implemented in Bitcoin, but proof of work is quite energy. Electrical energy in mining a Bitcoin is intensive. So proof of work based consensus mechanism increases the chances of mining new block. It requires more computational resources. So the upper 2 points are the weaknesses of proof of work based consensus mechanism. So that's why we are using the proof of stack based mechanism. What is proof of stack? Nodes on a network stack an amount of cryptocurrencies, the candidates to validate the new block and earn the fee from it. So seen it is also a proof of work, but here we are maintaining the stack of cryptocurrencies for validating the new block. So an algorithm chooses from the pool of candidates of the node which will validate the new block. This selection algorithm combines the quantity of stack who are going to amount of cryptocurrency. So with other factors like coin age based selection, randomization process to make the selection fair to everyone on the network. What is coin age based selection means? It is mainly to track the time every validator candidate node stays a validator. Older node becomes, the higher the chances it becoming the new validator. Random block selections means lowest hash value and highest stack who are having. So these are the validators we are used based on weighted combination of this becomes a new validator. Or coinage based selection who are going to weighted or the older node becomes the chances for mining that or creation of that block. What are the POS based mechanism workflow? First, node makes the transactions. Proof of algorithm puts all these transactions in a pool. All the nodes containing becomes a validator for the next block raises stack. After raising the stack, we are using the two algorithms like coinage or randomized block selection to select the validator. After selecting the validator, it verifies the all transactions and publishes the block. His stake still remained locked and forging reward is also not granted it. So that the nodes on the network can okay the new block. If the block is okay, the validator get the stack back when you are forging that one we are not granted, right? Still remain, we are locked that minus. So we have to remove that one, that locking mechanism, and we are providing reward to also when the block is added to the new block. If the algorithm is using coin-based mechanism to select validators, the validator's current blocks has its coins rest is coin age reset to 0. After that coin age, it will be reset to 0. It put him in a low priority for the next validator election. The block is not verified by other nodes on the network. Validator losses its stake is marked by the bad by the algorithm. The process again is from step 1 to forge the new block. So first, no, the node, if suppose here one node is there, it make a transaction. So it put into a pool, and who are the validators? The validators are raise a stack, and we are using the coin age or randomized block selection. If suppose it is the coin, suppose we are preferring the coin age, if the first who are aged here means who are most weighted to validate that block, he will get the he or she, the miner will get the chance. Otherwise we are using the randomized block means one block will be, I mean one miner will get chance to prove that stack. So first we have to log that miner. After, the node will be validated, so the new block will be created. And also when we are okay with that validated, we are giving the reward, and also we are removing that log, and we have to put them coin it as this coin, we coin age, or coin age means we are maintaining it as a 0, and put them into a lower priority of next validator selection. If suppose it is not verified, the network will be uh, recognized as the bad by the algorithm. The validator losses its stack also, the cryptocurrencies also its loss. And we are again making the process from first node, first step onwards. So this is the POS hash based mechanism workflow, proof of stake based mechanism workflow. Next, what are the features? What are the features of coin for proof of work? It has fixed coins in existence. So the finite number of coins that always circulate in the network. There is no existence of bringing new coins into existence. Note that note that the network starts with finite number of coins initially. Start with the proof of work. It's shifted to POS some cases. Transaction fee as a reward or miners or forgers. So every time, every transaction is charged some amount of fee. So this is accumulated given to the who forges the new block and found fraudulent or is not rewarded. Impractically of the 51% attack. Next, what are the advantages of POS? Means it is mainly energy efficient, decentralization, and security. Why energy efficient means? So every miner he is not wasted their energy and efficiency. Who are maintained that stack of coins are randomly we are selecting, right? So that amount of energy is not wasted here in maintaining the distributed consensus proof of stack based system, and provided like rewards also. So no extra edge is here. It promotes the decentralization, and also the 51% of this attack also we are reducing here. What is the weakness of POS mechanism? So large stack validators are waiting means it's somewhat disadvantages. Increased chances to increased selections also. If suppose the stakers means the miners are more means more forging reward earnings are there, and also huge currency can be shared, and it can causes the network to become like a centralized over time. Those who are having the more uh, coins are long weighted coins in a coin each selection that time. And also it is a new technology. POS is relatively new, and the research is ongoing, find flaws and fix them, making viable. Nothing at stack is a problem, but it describes the no disadvantage of the in case of the support multiple blockchains events of a blockchain split. So these are the different blockchain using proof of stack, Ethereum, Bitcoin. Next, These are the different various proof of stacks: regular proof of stack, delegated, least, master node proof of stack. This is the difference between proof of work and proof of stack. So validation method: miners solve complex puzzles to add new blocks to the blockchain. Validators creates a block and validate transaction based on cryptocurrency stack. Energy consumption: it requires more power and energy compared to POW. It has energy efficient. It does not require the solving complex puzzles. Who are having the more stack is here validator. In scalability, it forces the scalability issues, time consuming solving puzzles. Here, highest scalability processed more quickly. It offers higher scalability. Security means here the security are due to difficult of manipulating the blockchain. Here moderate security, and the risk of centralization is also there with the who are having the more stack. They are going to be validated every time. In decentralization, highly decentralized. Anyone can required hardware can participate. Moderately decentralized, who are having the large validators, the risk by the large validator. What are the scalability aspects of blockchain consensus protocols, permissioned blockchains? So, this some scalability challenges are there: transaction throughput, network latency, energy consumptions. So, it takes more time to create a new block or creates large support large scale applications. In network latency, the number of nodes in the network increases. It's a significant issue overall performance of the blockchain, and also it has more energies are required, like hardware, soft power is required. So what are the solutions means? So we are maintaining the sharding, dividing the network into smaller shards, and maintaining the subset of transactions like a parallel, increasing the overall transaction throughput. Next, off-chain transactions, reducing the loan and the remaining blockchain parallel processing, and consensus protocol optimization and interoperability. What are the permission blockchain scalability solutions? It's like a hyperledger fabric, and it is increases the parallel processing and modular uses the modular architecture. Code it is a distributed ledger architecture and off-chain transaction to increase the scalability forum. What are the scalability metrics means? We are maintaining the transactions is per second and block time, network latency, scalability ratio. What are the scalability limitations means? That is hardware limitation, network congestion, consensus protocol limitation. What are the types of blockchain means? Permission blockchain and permissionless blockchain. In permission blockchain means closed network with the limited decentralization, and additional access control layer is there and designated entities. In permissionless means it is open and decentralized. It is publicly available to everyone. Who are adding, anyone can join the network and possess a copy of the ledger. In permission blockchain means you have to first verify or you're getting the permissions to participate in that network. So these are the difference between the permissionless and permission blockchain. So it is private permissioned sandbox. Permissionless means it is public, trustless. And examples, permission blockchain is Ripple, permissionless means Bitcoin, Ethereum, and key attributes. It can be controlled transparency, development by private entities, not anonymous, privacy, and no single authority, may or may not involve digital assets. It is full transparency, development in open source, mostly anonymous, privacy dependent on like technological limitations, no control authority, involves in digital assets. The benefits means incremental decentralization, strong privacy, customizable, faster and scalable. Broader decentralization, highly transparent, censorship resistant, security resilient. These are the benefits. And drawbacks, limited decentralization, override risk, less transparency. And it is a less energy efficient, slow and difficult to scale. Use cases are, it is a business to business, business to consumer, government to organization. It is a peer-to-peer network, business to consumer, and government to citizen. So different aspects of permission blockchain means decisions are authorized by a private group. Security, decentralization is not fixed, means the fully centralized or partially decentralized. The members typically decide on the network level of decentralization, and transparency is not required. Lack of anonymity. Consensus mechanism means the permissions or the agreement we have to take here to participate in the network. Mainly three protocols we are used: practical Byzantine fault tolerance, federated Byzantine consensus, round robin. In PBFT protocol, all voting needs must reach a consensus. It is unreliable. One or more parties considered unreliable. In federated Byzantine consensus, set of transaction validated, trusted by each node in the blockchain. In round robin consensus, pseudo randomly to create blocks, a node must pass through the cooling off period before it can re-enter the pool and be available to the again for consensus participation. And advantages of the permission blockchain means, so high level privacy and security they can provide, flexibility is there, and permission blockchains are highly customizable and can accommodate configuration and based on the organization needs. Lastly, these type of blockchains both scalable and highly performant due to the limited number of nodes needed to manage transaction verification. And disadvantages means lack of transparency can be potential point, and in business context only we are developed. Additional layer of computational security is therefore security risks posed by the bad actors. Why permission blockchains are ideal for business applications? It is mainly the permissionless means anyone can join, the confidential and the integrity of the data can be misleading. So you have to maintain the who are authorized persons and the confidential matters we are storing in decentralized means the transparency is not there. So the financial transactions, know your customer, anti-money laundering, and supply chain provinces regulations must be followed. Participants must be identified, and the network needs to be permission, high transaction throughput performance, low latency of transaction confirmation, and privacy and confidentiality of transactions and data pertaining to business transactions. Business value, these requirements is added value for the permission blockchains. It is increases business velocity and multi-party business process also automated, and using the intermediaries, it reduces the cost and risk, and the fraud and the regulatory compliance also that reduces the cost and improve the data quality and timelines by avoiding offline reconciliation, and increases the auditability and trust, reduce the cost. Next, design goals. First, we'll see about the performance design goals: high transaction throughput, low latency, scalable network. Coming to the security design goals, it is we are following the immutable ledger, secure consensus, authentication, and authorization. In energy efficiency design goals, low energy consumption, sustainable network. In decentralization design goals, decentralized network, node incentivization. Interoperability design goals, interoperable network, and standardized protocols. Governance design goals is transparent governance and decentralized decision making. Scalability design goals means vertical and horizontal scalability we are providing. And consensus protocol for permission blockchain means we are using the PBFT, raft, tendermint, IBFT, proof of authority, delegated proof of stake, leased proof of stake, federated Byzantine agreement are used. Comparison of the different consensus protocols, security, scalability, performance. PBFT is high, medium, and medium. Raft is high security, medium scalability, medium performance. Tender means high security, high scalability, high performance. So this is the comparison of the consensus protocols. And what are the characteristics of the decentralized applications? It is a decentralized applications is following the decentralization like decentralized applications and openness, security, trustless transactions, tokenization and cryptocurrency, immutable and transparent data, and community governance. What are the main features of the blockchain is also the characteristics of the decentralized applications. Why means we are following decentralization process for the blockchain, right? So what are the main characteristics of blockchain means decentralization, openness and security, trustless transactions, tokenization and cryptocurrencies, immutable and transparent data, community governance. Next, setting up a private blockchain, multi-configurable blockchain using a multi-chain deployment scenarios of multi-chain. First, you have, whenever you are going to set up a private blockchain, first you have to define the purpose. Next, choose a blockchain platform. And next, you have to set up the network. And you have to configuring the nodes will participate in the private blockchain network configuration. And next, you are using the consensus mechanism and network permissions and smart contract development, deployment and testing, and maintenance and upgrades. These are the different steps while you are setting a private blockchain. Next, how you are performing the multiple configurable blockchains using multi-chain. First, installing and setup, create the first blockchain and create if you need any additional blockchains. And means here in multi-chain, we are interacting or exchanging between the different chains, right? Other chains. So if you need any additional blockchains, you can create connecting nodes to the blockchain, interact with the blockchain, managing interoperability, monitoring and maintenance. Next, deployment scenario of multi-chain. So whenever you are going to deploy the multi-chain, these are the different deployment scenarios. First one, enterprise and supply chain solutions, financial services and banking, healthcare and medical records, government and public sector, supply chain and trade finance, intellectual property management, Internet of Things. In centralized currency settlements, you are mainly verifying the central authority and account creation and transaction initiation, authorization and verification, fund transfer, confirmation and record keeping, and dispute resolution. These are the different currency settlements that typically works in decentralized uh, way compared to the centralized currency settlements. And bond issuance and peer-to-peer trading. In bond issuance, traditional bond issuance facing some problems. So the bonds is some bonds of the different persons, investors are issue who are going to be the capital issue bonds are raised by the different persons. It can be changed and the blockchain based bond issuance means we have to create smart contracts for self-executing agreements who are the main investors or issuers of the capital of the bond. And also blockchain based bond issuance scenario, we are creating a digital bonds as a tokenized assets in a blockchain platform, and we are maintaining some terms and conditions of the bond such as interest rate, maturity date, and coupon payment schedule and are coded with the smart contracts, and investor can purchase these tokenized bonds directly from the issuers in the secondary market. And advantages of the blockchain bond issue: it reduces the issuance cost and processing time and improve transparency and immutability of bond terms. It enhances the liquidity and accessibility for a broader range of investors and real-time tracking and verification of ownership. Coming to the peer-to-peer trading, blockchain based peer-to-peer trading means the financial compared to the traditional peer-to-peer meeting, blockchain is benefit. In blockchain-based trading scenario, you have to initiate the transfer of the bond token or interested buyers. Smart contract facilitate the transactions of upon the recipient of payments, and it is entire process is transparent, efficient, and recorded on the blockchain. What are the advantages of the blockchain? Lower transaction costs due to elimination of intermediaries, faster settlements times, reducing counterparty risk, increasing the accessibility to a global pool of investors, improved quality and price transparency. Next topic is consumer facing reward scheme in decentralized applications. Here some innovative and consumer facing rewards when leveraging the blockchain technology and cryptocurrencies. So how the consumer facing reward scheme can be implemented in decentralized application: who are the loyal are incentivizing their engagement in the consumer, they are only offering them rewards in tokenization rewards and smart contracts like Ethereum, loyalty levels of tiers, governance and voting, exchange and redemption, integration with partner networks, user-friendly interface, security and privacy. So these are the different consumer-facing reward scheme in a decentralization applications. In tokenization rewards means the native cryptocurrency or token within a DApp ecosystem. So the reward scheme can utilize only that persons only. In smart contract means who are the rules and conditions of the reward scheme is maintained. It executes the distribution of rewards based on the predefined criteria, and it ensures the transparency, immutability, and accuracy of the distribution. And we have to maintain the loyalty of the and governance and e-voting, exchanging, redemption, integration with partner network, security, and privacy. Thank you.